In this video, we will be looking at how to find the least common multiple, or LCM in short. The LCM is used to find the common denominator of fractions when adding, subtracting, or comparing them. First, I'm going to go over some steps and a few examples. But before we get started, let's give ourselves a definition of LCM. The definition of LCM is the smallest common multiple of two or more numbers. So let's write out the common multiples of 9 and 4. Okay, so for 9 we have 9, 18, 27, 36, 45. Let's just write out the first 5 for 9. And then for 4 we have 4, 8, 4, 8, 12, 16, 20, 24, 28, 32, and 36. So as you see, 36 is both the common is a multiple of 4 and 9. And also it is the smallest common multiple of 9 and 4. It seems pretty easy, but this method will take a really long time with bigger numbers. Let's go over the step-by-step process of finding the LCM. The first step is to draw out the factor tree. For those of you who do not know, the factor tree breaks the numbers down into their prime factors. We will be using the numbers 12 and 8, so let's break them down. Alright, so 12 breaks down into 3 and 4. 3 is the prime factor, so it can't be broken down anymore. But then 4 can come 2 and 2. Alright, so these are all prime factors, 3, 2, and 2. So let's do the same thing for 8. Alright, this can be broken down into 2, 4, and then for 4, 2, and 2. The second step is to determine repeating prime factors among the numbers. So for this scenario, there are 2 repeating prime factors. There's 2 2's. All right. And the third and final step is to multiply prime factors. So for repeated prime factors, you only multiply them once. Alright, so let's start writing them down. So 3 times 2. So these are the non-repeated prime factors. But then there are 2 2's. So instead of multiplying 4 more 2's, we're only going to multiply 2 more 2's. Because they're both repeated within the numbers. So therefore, 3 times 2 times 2 times 2 equals 24. And 24 is the least common multiple between 12 and 8. Let's find the LCM of 48 and 22. Let's draw out the factor trees for both numbers. So for 48, we have 24, and then 2, 12, and then 2, 6, and 2, 3. Alright. Well, for 22, it's just 2 and 11. They're both prime. In this case, there's only one repeating prime factor. There's 1, 2. Now let's multiply all of the prime factors together. 11 times 3 times 2 times 2 times 2, and then the repeated 1, 2. Alright, So then this comes out to 528. And that's the LCM of 48 and 22. Let's do another example with 3 numbers. Whoops, okay. Alright. 12, 7, and 5. Alright, so 7 and 5, they're both prime numbers. So they can't be broken down into any more factors. So for 12, let's break it down into its factors. 2, 6, 2, 3. Alright. So in this case, there are no repeating of prime factors. So let's just go straight to multiplying them. So 2 times 2 times 3 times 7 times 5. And that comes to a result of 420. Alright, and let's do another example with with 25, 33, and 99. Okay, so 25 can be simply broken down into 5 and 5. They're both prime numbers. They can't be factored down anymore. 33, 311, the same case. Then 99. This can be broken down into 3, 33, and then again 3 and 11. So the repeating prime factors here, 11 and 33 and 99, and then also 3 again, and 33 and 99. So let's multiply them. All right. So 5 times 5 times 3, and then the repeated prime factors 3 and 11. So again, even though there's 3 numbers, you still just multiply them once. So this comes to a result of 2,475. And for our final example, we're going to use the numbers 105, 63, and 36. So 105 can be broken down into 3, 35, and then 5 and 7. For 63, 3 and 21, and then 3 and 7. For 36, 2, 18, 2, 9, and then 3 and 3. So there are quite a few repeating prime factors here. So there's a 3 repeated in all numbers. There is, let's put 1 there, and then there's also a 3 repeated in 63 and 36, and then there's a 7 repeated in 105 and 63, and yeah, I think that's it. Alright, so now let's multiply them together. So 2 times 2 times 5 times 3 times 3 times 7, which comes to a result of 1,260.